Okay, 4.4 is finding the slope and rate of change. The slope of a non-vertical line is the ratio of the vertical change, the rise, to the horizontal change, the run. You'll hear a lot of rise over run. That means up or down, right or left. The slope of a line is represented by the letter M, where y2 minus y1 over x2 minus x1 is the equation for slope. A rate of change compares a change in one quantity to a change in the other. Okay? So we're going to look at this graph that we have for example 1. So we see we've got the y-axis, we've got the x-axis. You guys all have this on your paper. Okay, so we have a line that looks like this. Now, this is the hard part, because what you've got to do is find, you guys have lovely lines like this. Like this line extends all the way, right? These lines extend all the way, so it looks like cross hatches like this. Everybody with me? Yes? It looks like this. Okay, so what you've got to find is a point where it crosses those things perfectly. So I think one of the places it crosses it perfectly is right here at 1, 4. And another place I think it crosses perfectly is right here at 2, 2, 6. So this is negative 1, 4, and this is 2, 6. So now what we're going to do is we're going to find the difference between these. So we're going to see how much we go up and then how much we go over. Is everybody with me? Do we see where those cross perfectly? Those little cross hatches? Okay. So I'm going to go up. I go up 1, 2. So that's my rise. And I go my run. I go over 1, 2, 3. Rise, over, run. And see how I went up in the positive direction and right in the positive direction? This is my M. This is my slope. We've got the rise over the run. Any question about that? Confused? Yeah, and M means slope. So why don't we look at example 2? I'm going to draw this on the board, but while I'm drawing on the board, I want you to see if you can figure out the same slope as I'm going to get. So you're looking at example 2. You're on the back. Let's see if we can get the same slope. Okay, so the 2 points I'm going to use, because I feel that they cross perfectly, are points, let's see, 3, 4, and 4, negative 1. Okay, you see how those cross? Like when you're looking, you're like, okay, that crosses those cross hatches perfectly. Cody, walk over to Miss Carmel and get notes. Don't just sit there. So I'm going to see how much we're going down. To get from 3 to negative 1, I go 3, 2, 1, 0. 3, 2, 1, 0, negative 1. So I went down 4, and then I'm going to go over 1. So my slope is negative 4 because I'm going down.
That's a positive slope.
I'm going going down 4.
Oh.
I'm going down 4. So it's -4 over 1. That's my slope. This is my rise, and actually in this case it's fall, over run. If you go down to get from one dot to another, you have to do negative. No. Don't make that noise, please.
That would be -5.
Is it -5? Did I count wrong? I went down 4. Oh, yeah, it is. It's -5. Thank you. All right. Yes.
If it's -5 over 1,
It can just be -5. Yes. Let's look at example 3. Okay, example 3, I've got my y-axis, my x-axis, 1, 2, 3, 4, 1, 2, 3, 4, and I've got this line that goes right through 4. Okay, so we can pick any point on here, but does it fall or rise at all?
No.
No, so that's 0 on the top. And it doesn't matter how many I go over. I could go over 3. What is my slope?
0.
0. So my slope is 0. If it's a horizontal line, it's 0. Think about it. Slope is like walking up a hill. Are we going up or down at all?
Down.
We're walking on this hill. Are we going up or down at all?
We're not going
No,
up.
so we're going 0. So our slope is 0. On the last one, what was our slope? Were we going up or down? If I'm going from this point to this point, you
We're
always
going
walk
down.
left to right. I'm going down, so I know I'm going to have a negative slope. What about this one? If I'm walking from left to right,
You're going
up,
left.
so it's a positive slope. Okay? All right, let's go to the next page. Go to the next page. We're going to find this slope of this line. We've got our y-axis. We've got our x-axis. 1, 2, 3. And we've got, okay. So I'm just going to pick 2 random points. Let's pick 2, 3, 2, and let's pick 3, 0. How much am I going down between 2 and 3? 2 and 0. I'm going down 2, so it's -2. How much am I going right or left? 0. If there's a 0 on the bottom, we call that undefined. Do you think of it this way? Can you walk straight up and down?
Yeah. No.
No, you can't walk straight up the wall. You can go partway, but you're going to fall over. You can't make it all the way to the top. It's undefined. You can't walk it. It's undefined. So we've got positive slope, which I'm walking up. We've got negative slope where you're walking down. We've got 0 slope where you're just walking straight across. There's no up or down. And then we've got undefined. I can't walk it. Okay. Last thing on here is we've got a table. We've got a table that shows the cost of using a computer at an internet cafe for a given amount of time. We're going to find the rate of change using this table. So your table looks something like this, except yours looks much prettier. We've got time, cost, 2.7, 4.14, 6.21. Okay, if we're at 2 and we're going to 4, 2 going over to 4, how much did we go over? 2. Cost, I went from 7 to 14. How much did I go? That is my slope, 7 over 2. Remember, this is x, this is y. It's always y over x, or rise over run. Okay, so it's the amount I go from here to here. 14 to 21, how much is that? That's 7 as well. 4 to 6, how much is that? 2, so I know that's 2 as well. Are the stuff going up or are they going down?
Down.
Up, so we know it's positive. Okay? Any questions about this? Yes.
What happens, like you The two numbers are like that, but then the third number is different, so it doesn't.
It would not have a regular slope. And in that case, we wouldn't use it for these type of problems, but if you see that, you know that the slope changes. And when we get into exponential functions, you'll see stuff like that.
Yeah, oh, here's
Well, there's a classroom right next door.
a-